So question 5 is asking us to calculate the extent of reaction and the number average chain length for a hydroxy acid which has been polymerized to form a long chain polyester. So for this we're using an equation we've seen before, which is P equals N0 minus N divided by N0, where N0 is the initial number of molecules of our monomer, and N is the remaining number of molecules after time t. P is the extent of reaction, as we've said already. So we've been given in the question the number of molecules in a slightly different form. We've been given instead a concentration of our hydroxy acid in a solution. So if we consider this for our N0, we've been given 0.5 molars of hydroxy acid, and we also know that this is in a 3-litre solution. So considering the molar unit, a molar is the equivalent of a mole per decimeter cubed, and if you consider the litre is the equivalent of just a decimeter cubed, so that should be minus that. So a litre is just 1 decimeter cubed, and from this we essentially see that we are having 0.5 moles per every litre we have, so the total number of molecules we have will be 0.5 times 3. And if you consider the units of this, we'll do that separately, it's essentially 0.5 moles per decimeter cubed times 3 decimeter cubed. We'll see the minus 3 and the 3 here, they cancel out, and so we do have 1.5 moles. And so for N, we do the same essentially. We know that we have 2 times 10 to the minus 3 moles remaining after time t, so we times this again by 3, and we get 6 times 10 to the minus 3. So these two aren't really complete yet. Because we've just been given a number of moles, we need the number of molecules, and to do this, as we said earlier in another question, you just times the number of moles by Avogadro's number, and this yields the number of molecules you have. So if we put this into this equation again, we get P equals 1.5 times Na minus 6 times 10 to the minus 3 times Na again, and this will all over be the initial one, which is 1.5 times Na. So you can write that out fully as P equals 1.5 Na minus 6 times 10 to the minus 3 Na all over 1.5 Na. So what we can do here, instead of just putting in Avogadro's number, which is 6.023 times 10 to the 23, this is obviously, while not difficult, it's just unnecessary. So if instead we factorize this top part here, we take Na from both sides, we can see that we get this instead. And what I've done here, literally just taking the Na from each term, so if I were to multiply this out, you would be left by this top part here again. And we put this over the 1.5 Na again. We see that these two terms cancel out straight away, and thus we are just left with 1.5 minus 6 times 10 to the minus 3 all over 1.5. And if you put this into your calculator, this is equal to 1.494 over 1.5, which gives our P a value of 0.996. So the next part of this question is to determine xn, and as we remember before from Carruthers' equation, xn is equal to 1 over 1 minus p, and we already have p, so xn will be equal to 1 over 1 minus 0.996, which if we just put into our calculators, we'll see that xn is equal to 250, and that is the end of the question. So if you feel comfortable with that, go ahead. The main problem with this question is just the unit conversion. That's the main thing you need to get through your head. So as long as you're okay with that, you should be fine to progress.